Lublin from Xaoc Devices is a dual VCA with a difference. It has ping inputs which generate organic sounding decay envelopes modelled on the behaviour of vactrols. These envelopes only control the amplitude of the signal, not its frequency content, so it's not a low-pass gate. But because the inputs are DC coupled, it's easy to patch program one by adding a filter. The exponential decay curves mean it's great for synthesizing kick drums. As well as all sorts of percussive sounds like hi-hats. And you can create snappy, plucked synth tones without needing a separate envelope generator. This video is sponsored by Xaoc Devices, and in it I'll build a few patches to show you some of the musical applications for this deceptively simple VCA. Before I get into it, let's take a quick look at the panel and the controls. Lublin is a 6 HP module that consists of two identical unlinked VCAs, and they're DC coupled so they can process CV as well as audio. At first glance, it's almost identical to the Tarlin dual VCA with the same panel layout, but while Tarlin offers overdrive to modify the tone of the signals passing through it, Lublin is clean and transparent. It has a gain control circuit which limits the amount of amplification so that it can't exceed unity gain. Basically, if something comes out of this sounding distorted, it was already distorted when it went in. While Tarlin has linear and exponential CV inputs, Lublin only offers an exponential response. What it has instead is a ping input. Sending a gate or trigger here opens the VCA with an envelope that has a near instant attack and an adjustable decay time. These envelopes mimic the behaviour of vintage vactrol circuits, which famously sound very similar to the natural decay of plucked or struck acoustic instruments. There are three ranges for decay length: natural, shortened and prolonged, which you can select with this switch. The knob at the top acts as a simple attenuator or volume control when nothing's connected to the CV or ping inputs. When Lublin is being pinged, the knob controls the decay time, and when it's being CV controlled, the knob attenuates the incoming CV. Because the inputs are DC coupled, you can use it as an envelope generator to control other modules by simply patching a fixed offset voltage to the input and pinging it, which I'll demonstrate in some of the patches. And that's basically it control-wise, nice and simple, so let's get patching and make some music with it. Okay, let's get started with a patch that uses the two halves of Lublin independently as two separate VCAs and envelope generators for two synth voices. In this patch I'm going to use Berlin and Jena together as a wavetable oscillator connected via the Leibniz bus, and the output of that is going into channel B of Lublin, and I'm going to ping it using gates from the Moskwa sequencer off screen. That's also sending note information to the volt per octave input of Berlin. So if I start a little sparse sequence going, we can have a listen to the vactrol-style decay curves of these pinged envelopes. Let's get that going. And with the switch in the natural position and the pot at 12 o'clock, we get this kind of classic, almost instant attack, nice plucky exponential decay, and if we play with this pot we can make that decay longer, more fuller bodied, and at the other extreme it gets even pluckier and very short. Let's flick the switch to the prolonged response, and you can hear at 12 o'clock it's got a lot more body. Not so much the decay time that's longer, it's more that the amplitude curve doesn't drop down so sharply, so we get a bit more of this kind of body of the sound in the middle of the cycle. So you can get much more kind of full-bodied envelopes in the prolonged setting. And then conversely in the shortened setting, we get these very extremely plucky, you can hear it kind of ringing vactrol style after that initial transient. But it's very, very faint. And this response is much more useful for percussive sounds. It's almost too short really for melodic material. But you'll hear in one of the later patches it's great for things like hi-hats and percussion. And the very shortest setting, it's just little more than a click. So let's go back into the natural decay time. And let's just flesh this voice out a bit. I've got a slow attenuated sine LFO from Batumi, which I'm going to use to modulate the shape on Jena. So we can sweep through a few more interesting waves. And let's add a little bit of delay from Sarajevo. And let's Let's give it a bath and some nice reverb from MFX as well. I find for these kind of synthetic tones, it's really nice to have this organic, plucky kind of envelope, which almost gives it a slightly percussive feel, but slightly bell-like on some of these waves. So we'll leave it there for now. Let's listen to the second voice, which is going to be coming from Odessa. And for this I'm doing something slightly different. I'm using a combination of an external envelope to the exponential CV input. And if I get this going, I'm using Xaoc here to send in a similar shape envelope to the internal one, but with a slightly slower attack, a sustained peak, and then a long exponential tail over a course of a bar. So it's not plucky, it's kind of sustained. But what we can do that's quite interesting is use the ping input simultaneously. So I've got a little pattern of triggers from PAMs which I can feed into the ping input, and they're going to come into the second half of that bar and give us this little rhythmic addition. And if I flick that switch to prolonged, we can kind of dial in. Got a couple of other bits of modulation happening on Odessa. I've got a second envelope which is kind of stepped rising, which is modulating the tilt, quite heavily attenuated, but just giving us a little bit of a rising harmonic spectrum. And I've got a slow attenuated LFO to the warp setting on the comb filter, just to keep the sound kind of evolving. And again, if I give this a load of reverb, got a nice mix of sort of sustained and plucky percussive elements. And let's just bring in our first voice again. Let's bring in a few extra notes to that sequence. And bring in some drums. So, as I mentioned in the intro, Lublin isn't a low-pass gate. Although it's pingable and it has this vactrol-style decay curve, it doesn't affect the frequency content of the sound passing through it, just the amplitude. Whereas a low-pass gate is a combination of a low-pass filter and a VCA, so as the sound decays, it gets darker, which is part of the kind of classic LPG sound. However, we can patch program an LPG with Lublin by using an external filter, by taking advantage of the fact that it's DC coupled, so we can feed in a constant offset voltage into one of the inputs, and then when we ping it, that voltage will decay according to the same shape as the vactrol-style curve, and we can use that to modulate the FM input on a filter. So I've got set up here Sophia as my oscillator. That's running through Belgrade filter, which is currently wide open in low pass mode. No resonance, shouldn't be doing any filtering at all. So the sound will pass through there relatively clean into the first channel of Lublin. And I've got a sequence from Moskva. I'm going to use the gate output of that sequence multed to ping both sides of Lublin, and the volt per octaves going into Sophia. And that sequence sounds like this. At the moment, Sophia's just playing its kind of saturated sine tone. I haven't got any of the ripple elements active, so it's a really simple, not a huge amount of harmonic content in this, but enough to kind of get us going. And you'll hear that it's got that nice rubbery vactrol style decay, but the sound is, the frequencies content is pretty constant as that decays. It's not getting darker. So it doesn't sound quite like a low-pass gate, basically. If we take this 5-volt offset from Samara, if I turn the little red button on there and max channel 1, that means we get 5 volts out of the first channel. And let's go into the other side of Lublin, channel B. And if you look at the scope that's running through the blue trace there, we can see the shape of that decay envelope. And you'll notice it kind of matches the amplitude contour of the audio, which is on the green trace. Got them set, they're both in natural mode, in the middle position of the switch, set to a fairly short and snappy decay time. So if I was to turn down the Belgrade filter, so we're kind of inaudible, but then bring up the FM where I'm routing this blue trace to, or this envelope, we now get this much more LPG style sound where we're getting a bit of filtering happening, or darkening of the sound as the decay closes. And the advantage of patch programming it this way is we get independent control over those two envelopes, and we get full control over the filter as well. There's various different filter types in Belgrade. We could do high pass gates or band pass gates, whatever we like. Let's just switch to one of the slightly more aggressive filter types here, add a little bit of resonance. And we could make that filter envelope a bit snappier. Let the amplitude ring out a bit more. It's even more obvious when we bring in a bit more harmonic content from Sophia, so if I mix across to some of those ripple elements as well. You get this nice rubbery, LPG-ish kind of tone. And just to compare it again, let me just open the filter fully again. So without enveloping that filter, we're getting this kind of constant spectrum, whereas if we allow this blue envelope to filter it for us, so by having independent control over the two envelopes and our choice of filter, it opens up a really rich palette of possibilities that go way beyond a kind of fixed architecture LPG. So let's have a look at using Lublin to help us synthesize kick drums using its pingable envelopes. I'm going to use as the sound source Batumi Mark II, which is an LFO which also operates in audio rate if you turn the frequency up. So I'm going to use the first channel of that, and I'm just going to take the sine wave output into channel 1. I've got a trigger, a sort of 4/4 kick drum pattern trigger coming into this mult, which I'm going to mult to both ping inputs on both sides. I'm only using channel 1 at the moment, and if I just get that going, we're just getting that kind of really simple sine wave being pinged. If you listen carefully, you might hear that the very start of each hit is slightly different. Sometimes they're more clicky, and you can see on the scope as well. In fact, if I take this down to below audio rate again, back into LFO, you'll see on the scope more obviously. What's happening is it's oscillating continuously, and then when the ping happens, it's opening the VCA. That might happen mid-cycle, it might happen near the 0 point, but it's not consistent. So one thing we can do to help make that sound more consistent is take a copy of that trigger and go into the reset, and now you'll notice on the scope that every hit is identical now. It's starting at 0. So if I bring this back up into audio rates, it's a lot more consistent. It's actually not perfect because the attack is so fast on these ping envelopes. It's still going to have a discontinuity where the cycle is just before it opens. But it's a lot better, and we can disguise it by the next element we're going to add, which is a pitch envelope to the start of the note as well. And I'm also going to show you an alternative way to do this with an external envelope in a minute too. So let's tune this down slightly, and let's take a 5-volt offset voltage, which I'm just going to take from channel 1 of Samara, and we'll go into channel 2 again, just like we did for the LPG patch. So we're now generating an envelope on channel 2 effectively. Again, I've got both the switches in the natural setting for the time being at 12 o'clock, and we're getting a second envelope here. And if I take that, which is running through the scope, the blue trace, into the FM input of Batumi, I can start to introduce a bit of pitch change. And if I bring the overall pitch down a bit more, we're now getting something that's a bit more of a classic punchy kick drum with that kind of transient at the start, that kind of attack. And if I flick into the prolonged mode on channel 1, we get a much more boomy, compressed kind of sound with real body to it because of the shape of that envelope. And prolonged mode keeps it high for a bit longer, and we can play with the length of the pitch envelope as well, or the decay on it. Get it kind of clicky chunkier or more obvious. I quite like it in this kind of, gives it a little bit of bite at the start. Now if the attack portion of that initial transient is really important, if you're not just going to sample this and then use it repeatedly, if you're going to actually synthesize it, you might want to try using an external envelope instead of the pinged envelope on the main channel, because that way you can add a tiny bit of attack, which will just allow that start to be a bit more consistent. So let's just try that. I'm going to take, instead of pinging the first channel, I'm going to hit ZR over here, the first channel, which has got a similar kind of envelope, just an exponential decay. Let's go into the exponential CV input. I've been playing with the length and the shape here, and now we've got a much more consistent start to the hit. If I play with this pitch envelope, we can get a very short, choppy kind of start to it, or we can could play with maybe a triangle instead of a sine if we wanted a slightly more aggressive tone. And using an external envelope like this gives us control over quite a lot of aspects of the sound. Now these snappy envelopes in Lublin are great for synthesizing all kinds of percussion sounds, including hi-hats, which is what I'm going to try next. To do that, I'm going to use a mix of white noise and a kind of detuned oscillator cluster, similar to the way the 808 hi-hat circuit uses a bunch of detuned pulse waves. I'm going to use a white noise module off screen, which sounds like this. Just your common garden noise. And for the detuned oscillator cluster, I'm going to use a Dessa, which I've got with the spread and tension turned up a bit, and some settings on the comb filter, which sounds like this. Pretty unpleasant on its own, but once we start mixing them together, bandpass filtering them and putting them through Lublin with a short snappy envelope, we'll get something that sounds a bit more interesting. So let's have a listen. If I turn up the noise to start with and then get a little trigger pattern going. So this is with the natural envelope setting at 12 o'clock, so it's quite a long decay. Let's just shorten that slightly. And let's mix in some of that Odessa noise, and that gives it a slightly more metallic edge, a bit like a cymbal being struck. I'll take the noise out. You can hear that on its own. And this is quite a common way to approach hi-hats. You have a kind of metallic noise element and a noise element. And by carefully adjusting that mix, these are being mixed together through Zagreb in bandpass filter mode with a little bit of resonance. So you can kind of tune in to a frequency that works. And let's flick this length switch of the envelope to shortened. And now we get a very, very snappy, very short kind of electronic hi-hat sound. Now I've got another trigger pattern going to the second channel, which I'm going to keep in normal envelope mode. And this will be my kind of open hi-hat. So there we go, without any external envelopes and just with these two VCAs with the ping input, we've got pretty cool electronic hi-hat synth. And I can adjust the balance of the metallic and noise elements. With the filtering, give it more or less body. We'll just layer a little kick underneath. Okay, to finish, I've set up a fairly simple patch that uses the two outputs of Odessa to the two inputs of Lublin. I'm going to pan them slightly left and right, not hard left and right, but enough to kind of spatialize them a bit and play with some plucked stereo chords. I've got a chord sequence via the Hell expander for Odessa, which is being driven from Harmonaig by Instro just off screen. And I'm sending a Euclidean trigger pattern through a Bernoulli gate with 50-50 probability, so it's going to ping the two channels of Lublin, which I pan slightly left and right. Not hard left and right, but enough to kind of spatialize it a bit. And you can see on the scope it's basically randomly choosing which side it plucks, or strikes, or pings. At the moment, the odd and even outputs of Odessa have got the same spectral content. I've just got a very simple saw wavy kind of tone patched up on a Dessa. But if I was to start to play with the bank length, we're now getting different spectral content on each side as the harmonic partials are divided between the two outputs. And I can also play with the harmonic factor here, which will kind of transpose the even side up an octave all through the harmonic series. So I'll keep it like that. Let me just increase the bank a bit more. That's quite nice. And we can play with the spectral tilt as well, which kind of acts a bit like a filter in this setup. It's had a little bit of delay from Sarajevo via the mixer. What's quite nice is we can play with the decay times of those pinged envelopes independently as well. So this gives this simple chord sequence quite a nice dynamic feel. I can just play with the chord voicing as well. Of course, this is as much a demo of a Dessa as anything else. Let's just play with the comb filter density as well. Not really modulating any parameters here with CV, it's just nice to play manually and find some sweet spots. In certain settings we get these nice kind of almost percussive bell-like tones, especially if we bring that ping envelope down a bit. So I'll leave it there for now. Hopefully this video has given you an idea of what Lublin's capable of. If you've enjoyed it, please subscribe to the channel and leave a comment or a like. Thanks very much for watching, and I'll see you next time.